students, we will solve some questions based on trigonometric equations today. Let's see the first question. We are given tan x plus cot x is equal to 2 and we have to find the value of sin x. Okay. So this cot x can be written as 1 by tan x. If you multiply with tan x, then we get this equation. It's quadratic equation in tan x. This is how you can write it. From here you get tan x minus 1 equal to 0 or tan x equal to 1. Now if tan x is equal to 1, x either lies in the first quadrant or lies in the third quadrant. So possible solutions would be x is equal to pi by 4 or x is equal to pi plus pi by 4. Okay, which is 5 pi by 4. So two possible solutions. Now we need to find the values of sin x. So sin x equals sin pi by 4, which is 1 by root 2, or sin x equals sin pi plus pi by 4, which is minus sin pi by 4, hence minus 1 by root 2. So the possible solutions would be plus minus 1 by root 2. Okay. We'll now try another question. Now second question. The given equation is sin x minus pi by 2 plus 1 equal to 0. And we have to answer in which of these intervals exactly one root would be there. Exactly one solution would be there in which of these intervals for this equation. Let's solve. I can rewrite this equation as sin x equal to pi by 2 minus 1. Put the value of pi. This is what you get. Sin x is equal to plus 0.57. So as sin x has a positive value, sin x is positive in first quadrant and second quadrant. So we'll be having one solution in the first quadrant and one solution in the second quadrant. So one root lies in 0 to pi by 2 means first quadrant, and another root lies in pi by 2 to pi, which is second quadrant. Okay. Now let's check the options. Option A says 0 to pi. 0 to pi means first and second quadrant both. So total number of roots here would be 2. So A part is not the answer. Option B, pi to 3 pi by 2 is third quadrant. We don't have a solution there, so this is not the answer. C part, pi by 2 to pi, which is second quadrant, and in second quadrant we have exactly one root. So this is our answer. So answer would be C part. Okay. Let's try another question. Let's try the next question. We have to find general solution of this given equation. This is the given equation. So from the first two terms I can take 4 sin x cosine x common, and taking this 4 on the other side we get minus 1. Now this can be written as, while cos square x minus sin square x is cosine 2x. We can combine these and write as sin 4x. So sin 4x equal to minus 1. So sin theta equals minus 1 when theta is 3 pi by 2. So from here you get 4x equal to 3 pi by 2. Now to get the general solution, we'll add 2 in pi to it. Now this gives me the value of x as 3 pi by 8 plus n pi by 2, which means this is the correct option. Okay. So we'll try another question now. Next question, we have to find general solution of this equation. Now in this case we'll divide on both the sides by root 2. Why root 2? I'll tell you. The coefficient of sin x is 1, coefficient of cos x is also 1. So 1 square plus 1 square under the root is root 2. So we'll divide by root 2 on both the sides. Now we can write 1 by root 2 as cos pi by 4, and similarly here I'll write as sin pi by 4. Now this can be clubbed into a single sine function if we use the formula of sin a plus b. Sin a plus b is sin a cos b plus cos a sin b. Using that result, you can write like this. Now if you know the general equation sin x equal to sin alpha and its solution, you can write this as, which will give me this result. This is the general solution for the given equation, and if you see the options, option D seems to be the correct answer. Okay, thank you. Okay, let's solve this question. There's a given equation. We have to find how many real roots are possible. So step 1 would be, I put sin square x equal to t in this equation. So this is what we get. This is a quadratic equation in t. We can solve it using the quadratic formula. T would be equal to minus b upon 2a. Okay, so from here you get this can be, this is 4 plus 4 can be written as 2 root 2. Now because t is equal to sin square x, it must be positive, so we reject the negative root and t is equal to 1 plus root 2 if we reject negative root. Now put back the value of t. T is sin square x, so we get sin square x equal to 1 plus root 2. Root 2, if you know, is 1.414, so sin square x is equal to 2.414. Now the value of sin x lies from minus 1 to plus 1, so sin square x in any case must vary from 0 to 1. So the maximum value it can take is plus 1. It cannot take a value 2.414, hence this is not possible. So we have no solution or no real roots possible for the given equation. So answer to the question would be 0. We don't have any roots possible. Okay, thank you.